morning, everyone. Just want to check again if everyone can hear me or not. Maybe you can type in the Zoom chat. Okay, thank you. So it is 10 o'clock now. Maybe I will get started. Okay, all right. Yep, here we go. All right, I will start now. Yep. Good morning, everyone. Welcome everyone to Fit 2107 Software Quality and Testing again. My name is Clark Tantitam Tawon. I will teach this week. So this is week 3 now. So today we will cover about the unit testing and the CI/CD. Okay. And yeah, so by today, right, by the end of this lecture, we will talk about what is the unit testing, how can we do it in Python, what is the purpose of the unit testing, what are the benefits, how can we write the effective test cases, how can we execute the test case using the doc test, using the unit test framework and the CI/CD as well. I believe everyone had played around with the doc test, and this is some of the feedback so far. So based on the first question, it seems that 91% of the student, we received over 100 response. Thank you so much, everyone. And I, as a CE and the lecturer, I actually decide the coding part, try to make the unit more practical, more enjoyable, more hands-on, right? And I just feel that what I did is actually quite successful. Thank you so much, everyone. I found that 91% of the students quite enjoy the unit so far. So, and these are some of the qualitative feedback, right? Like most of the students actually like the coding part, writing the test cases. So from the week 3 onwards, we will focus more on the hands-on thing. We will write more test cases anyway, and especially in the assignment as well. Okay. Okay, fantastic, everyone. Thank you so much. Really appreciate. That's the first thing that I really want to tell, and then we will get back to the materials, the core content of this week, which is about unit testing. So in short, right, unit testing is part of the software development process where we want to test the smallest part of the programs to ensure that they are correct, right? They are functionally correct, they are implemented correctly. So unit is the smallest unit of the code anyway, and we want to test it, okay? So the purpose of the unit testing, we want to verify whether the code that we are implementing is correct or not, right? And we want to identify the bug as much as possible. Think about the software design patterns. We want to avoid the code that is like highly coupled, but more like a cohesion, that kind of thing. So we want to make sure that the function or the methods that we are writing, they are not independent with they are not dependent with each other. They should be independent. It should be at the unit level, the clear each of the method should have a clear purpose. What is the expected input and what are the expected output, right? So that's why we need to, that's about the design pattern, and we need to do the unit testing, okay? And think about the software development process like nowadays. I'll just look at this figure. Let's take a look at this figure together, and I will try to get the annotation now. Okay, so normally we are, as a developer, we will start develop the code, okay, implement something based on the requirement, and we will write the unit test, okay, ensure that everything is passed, the code that we are writing is correct. Then once the unit or the contribution of the code that we are writing is correct, then we can submit a pull request, okay, to the main repository, right? To the repo, okay. Then we will ask someone else, that's part of the code review process now, to review the code. If they are approved that, then that piece of code will be integrated or merged into the main repository. And before that, during the pull request, we will need to run the CI/CD pipeline as well, right? So basically, CI/CD for here is more like an integration part. Even if we implement our unit function correctly, but it doesn't mean that it will work well with the other functions, right? So the purpose of having the CI/CD is to automatically run integration tests for every unit and everything. Everything is integrated together automatically. So, and that means once the CI/CD is passed, then that kind of code will be automatically merged to the main repository. Okay, so that's the purpose of what we are doing today. We'll talk about the unit test, and then we will talk about the CI/CD later as well. Okay, yeah, mouse. So that's what we are going to cover today. This is just a recap. When we talk about unit testing, for each of the method, we normally have the input arguments and the return value, right? So when we decide the test cases, they are the same. We should have just a recap again, okay? Draw here. Normally, we should have the ID. What is the test case ID? Let's say if we are doing in the documentation part, we need to have the ID, itemize it. What is the test description? What do we want to test? And what is the test scenarios? Why do we do it, right? So it should provide some details, some description. Whether do we need some assumption or not? For example, if we want to test like, what is that? Viewing transaction history, probably the assumption or the precondition is that the user must have must successfully log into the system, to the mobile banking account. That kind of thing. And what is the test input, right? Think about the withdrawal money, okay? What is the withdrawal amount, and what is the amount that are currently available in the account, something like that. What is the test input, how to test it, okay? And what is the expected output. Once we implement the test case, we will get the actual output here. Think about the doc test, okay, that we do the last week. Multiply function, 2 by 3 multiply 2, okay, 3, okay. So we expect to be 6. That's the expected output. And if the actual output is also 6, that means this test case is passing, otherwise fail. Okay, that's the basic fundamental definition, notation, language that we are talking about the test case, about testing, okay? We are talking about the test input, expected output, and the actual output, and whether the test oracle is pass or fail, okay? That's right. Yep, and but this is what we are doing is the test case. But think about the multiplication function, right? The input will be an integer number, and the input space is very large. That's like what is that? To the power of 32. That's the integer, right? What is it? No, wait. Okay, back here. Okay, so multiply, okay, we take the integer, and the integer has the input space of the 2 to the power of 32. That's a large input space, and the key question here is that, do we really need to test every possible numbers here? Because everything will go to the same scenario anyway. That means that's an invalid test input, right? And it will return some positive integer number anyway. So if we want to design the test case effectively, probably we should focus on different test scenarios instead. Okay, so there are two key differences here, right? Okay, clear. Yeah, we are talking about the test case and the test scenario in the next slide. Here, test case and the test scenarios. So test case is just one test data that we are used to test, but test scenario is just a scenario that we really want to test. Okay, to make it more concrete. Let's think about this requirement. We have an application, okay? This is the mobile application. We have the username and the password, right? And we have the button here to click login. All right. We have for this scenario, for this case, we have to input data, which will be the string of the username, okay, and the string of the password. Probably username and the password may have some requirement. For example, it must be x numbers of minimum x characters, that kind of thing. Okay, we won't talk about that. We'll talk about like a high level high level scenarios here, right? So based on these scenarios, that from what I can think of, there are actually 4 possible scenarios. We are talking about valid username, valid password. Okay, we just have one test case here with one valid username and a valid password in order to test something, okay? And then probably return true. That's a successful login, right? But the other 3 cases, they are like they are about unsuccessful login. Okay, so there are 3 possible scenarios. That means valid username but invalid password. Probably it will return some message like your password is invalid, or invalid username and but valid password. It is also possible as well. Probably the error message could be your username is not found, right? Or we can say another scenario is an invalid username and an invalid password. So the error message could be your username and password do not match. Okay, that's a possible scenarios. That's the minimum. But if the requirements say that, okay, the username must be a valid email address, the password must be at the minimum 8 character containing special character with at least X numbers of capital letters and lowercase, whatever, right? So that's a more complex requirement and we need to break it down. That will be more scenarios as well. So that's the thing. We are talking about the test scenarios and the ideal case, okay? Because we cannot test everything. Exhaustive testing will be very expensive and time consuming. Ideal case, we normally test just only 1 test case per scenario. At the minimum, right? Minimum, it should be 1 valid test scenario and the invalid test scenarios. Okay, someone raise the hand or not? Let me see. I see something. No, nothing. If you have any question, just post in the Zoom chat or the Q&A. I will try to monitor it as well. Okay. All right. At the minimum, I would say, okay, let me rephrase this one again. In this case, at the minimum, we should have at least 1 valid test scenarios, okay, and the invalid test input, right? Valid test input and the invalid test input. But in this case, we can break it down further as well. There are 3 possible invalid test input, so we can test it. The more you test, then the more reliable is your code as well. Okay, make sense, everyone? Say yes in the Zoom chat. Yeah. All clear? Yes or no? Yes. Okay. Thank you. Yeah, that's a test case and the test scenarios here, right? And again, as I mentioned before, we cannot test everything and it takes too much time. So that's why we should have some principles how to design the most effective test cases. The most effective one is that we should have the minimum numbers of test cases that can achieve the highest numbers of code coverage, right? So let's say we have 1 test case, but cover everything. That's the perfect one, right? But if we have 1 test case and it can test just only 1 line, that's not really useful anyway for that test case, okay? Because then we will need like another 10 more test cases to test another 10 lines. That's not great at all, right? So these are the key principles. It should be simple. The test case should be simple, understandable by itself. If we want to test the username and the password, username should be simple, like clear. right? Keep the user in mind as well. We need to put the user in our foot, and then we understand like we should test the program from the user perspective, not the developer's perspective, okay? The third one, we should avoid repetition. As I mentioned before, the test cases should not be repetitive. For example, the multiply of the 2 by 3 is the same as the 3 by 2. The result will be the same. The scenario is the same. It is repetitive and it means nothing. If we have another test case like that, it's not effective at all, right? So as I mentioned before, the most effective test suite is we have the smallest numbers of the test cases that can achieve the highest test coverage, okay? That's the best principle. And we should not have any assumption. We should avoid that. Do not assume that it's going to be like that. It's going to be like this. When we decide the test case, it should be associated with the requirement only. We decide the test case based on the requirement, not based on the code. All right. We write the code something and then we decide the test to match the code. It doesn't work at all. We need to decide the test case based on the requirement only. Whatever the requirement is written, we should decide the test case based on requirement, and then we write the code to pass the test case only, okay? And the fifth principle here, right? We should try to decide the test case to achieve 100% coverage. We will talk about what the coverage means later as well. It should be identifiable. We should use some systematic testing technique. This part we will cover from next week onwards. That's the black box testing, specification testing. We will talk about that. It should be self-cleaning. It should be repeatable. Repeatable means that it should be deterministic. When we run some function, we run some test cases, the output should be the same every time. It should not be random at all. So that means when we test something, we should avoid using the random number, all right? Random, we should avoid the random number to ensure that we can get the same output, right? Yeah, peer review. Test case can be peer review as well. When someone writes the test case, the other person can also review the test case whether it does make any sense or not as well, right? Okay, so these are the principles here. I would like encourage everyone to keep in mind when you work on the assignment as well. Okay, unit testing. We are talking about unit testing at the beginning, and this is more practice now, how to do it, right? Normally, when we do unit testing, we need to write the assert function. So we want assert means that we want to assert something, okay? Let's say this one. Let's say assert, we want to assert the summation function. We want to check whether the return value of the summation of the 1, 2, and 3 is the same as 6 or not, right? And this is just the message here. That's how we test something, okay? And this is the valid case, the valid input, right? Expected output is the same as the actual output. So this test case is passed, all fine. Yeah, but just in case that if something is wrong, right? That means if we assert summation of the 1, 1, 1 here, we actually expect to be 3. We actually expect to be 3, but actually we write it 6 here. So when the test case is failed, it doesn't mean that the code is incorrect, right? Sometimes the test case can be incorrect as well, because we design the test case based on the code or based on the requirement, right? Okay. Okay. Yeah, so what is the difference between assert and the dot test? Yeah, we will cover that as well. Yep, thanks for that question. Clear. And yep, that's a basic fundamental of the unit testing, okay? Normally we use the assertion. And then because to test unit function in Python, I would say there are 3 ways, okay? 3 ways. The first one is the dot test. The second one is the unit testing. And the third one is using the PyTest runner, PyTest framework. Okay, where are we here? Okay, actually wait, let me think. Let me continue. Okay, assert is the way we use to write the test case. Okay, and for this one, let's say if we want to run the test case here, we can write the test case like this, assert. And wait 1 second, draw. Okay, so let's say if we want to write a test case in Python, we did before, we use the doc test, but let's say right now we want to do the assertion here, right? So we can just write the assert function here and test something, run the test case. This is the easiest approach, okay? And then there's a question about, sorry, I get lost here. That's an assert, okay? And now, what is a doc test? Let's go through the doc test first, and then I will compare what is the difference between assertion, doc test, and the unit test. Okay. So doc test we did before last week. It is a testing framework that allows you to embed the test case within the doc string of your Python code. We did before, and that means we don't need to. We just write the test case using the prompt style, okay, in the doc string. Okay, this is what we do. And so doc test use the doc string to do the test automation, right? And let's say if we do want to test the multiply function of the a and the b, we just write the prompt in the doc string here. Multiply 2 by 3, we'll get 6. And let's see what the results are, okay? And when we run the when we run the doc test, this is the command that we normally use. Okay, we're gonna run the module doc test, and verbose it means that we want to print the result and what are the Python file that we want to test. Okay, so when we run this Python command on this file, okay, that means what is that? These are the results that we are going to get. That so we want to test multiply function of the 2 by 3. We expect 6, and if we get the same as 6, that means it is okay. We pass the test case. Okay. So in summary here, these are the summaries, right? There are 2 test cases. 2 test cases are passed, so everything is passed. Nothing is failed. Okay. All good. So this is when it fails. Okay, I'm sure everyone did try before as well. If because this is a multiplied by b, if we let's assume that we implemented incorrectly, right? So instead of return a multiplied by b, we just return a plus b, and the test case is failed. Okay, then that's why everything is broken here. Okay, all right. What is the difference? That's the key point here, right? When we do the doc test or the assert here, basic assert here, we don't use the assertion. We can only assert, we can only test whether the actual output is the same as the expected output or not. We can only test only like one scenarios, okay? It is the same when we do the assert like this, or when we do the doc test like this, it is the same as the assert equal, okay? It's the same as the assert equal here, okay? That means in real world scenarios, there are different kinds of assertion function as well. But if we don't use the unit testing framework, we cannot use any kind of any of this function. For example, if we want to test whether like let's say, how can I say, so in the studio task, there will be one in the studio this week, there will be one task about the gym eligibility, let's say. And let's say anyone who is eligible for the gym membership should be older than 18 years old, right? Older than 18 years old. We cannot use the assert equal. If we want to do that, it means that we want to test like every possible numbers, which does not make any sense. That's why we may need to use the unit testing framework instead and use the method assert greater equal something, okay? That means we want to test that age here, okay, is greater than 18 years old. Then they are eligible for the gym membership. So that means the reason of using unit testing framework or the Pi unit test, it increase the flexibility, the functionality to do the testing rather than just assert equal like in the doc test or in the, what is that, basic assert function. Okay, does it make sense? Maybe yes in the Zoom chat. If no, then I can clarify again. Yes. Okay. Thank you. Thank you. Thank you. Okay. So that's one of the reason why we need the unit testing. Okay. Why we need to use the unit test library within the Python. Okay. So the unit test, or sometimes people call PyUnit here, it is a comprehensive testing framework built in for the Python programming language, right? And it provides a full set of the testing features. It can do like a test picture, test discovery, test suite, everything, all of the possible test scenarios. We can do the mocking, everything, okay? And what we do, right? So to write the unit test here, draw again, we need to inherit the unit test class from this one, okay? Normally when we write the unit test, we need to import unit test and then create a class, inherit from this one, unit test.test case, okay? And then within the test class here, we need to write the method name start with the test, okay? And each test case can have multiple test method as well, okay? So let's say this is a test file, okay? Test file, import unit test class. We want to test something, inherit from the unit test and define the test method here. Start with the test, okay? Self, okay, yep. And then everything will be the test case, the unit, the assert statement here. Okay, this is how we write the unit test. I will show you the example in the next slide as well. Okay, yeah. So because of using the unit test, it provide like a comprehensive testing functionality. It can do lots of complex things. That's why we most of people using the unit test instead of the doc test or the basic assert function. Okay, to do that. Okay, this is how we do it, and we're gonna practice it in the studio as well. We the first and foremost, we will start importing the unit test from the standard library. Okay, start from this one, and we will create a class here called testsum. Okay, and inherit this class from the unit test.test case. All right, and this is the first test method. We want to test the basic summation function. So the summation of anything, okay, we return this one, okay. So these are the test scenarios here. We want to test the first scenarios, just a basic integer, right? So the summation of the 1, 2, and 3, it should return 6. Okay, that's the first scenarios. And we can test the summation of the tuple as well, right? We can do the summation of the array or whatever, whatever it is possible. So that are different scenarios here. And because we have only this class, it cannot be executed by itself. So that's why we need to have the last two lines as well to when we run, to ensure that when we run in the command line, the entry point will be this one, right? Unit test.main, okay, to run the unit test here. Okay, so let's say that if we run something and how to run it, right? Yeah, mouse. Okay, when we run it, we just call that Python file, Python testsum unit test, and it will present the results here, right? So dot mean that test case is passed. So in this, in the previous slide, we have only two test method, okay? The first test method is passed. The last, the second one is failed. So it will show as F. All right, it is fail. Test some tuple is fail. Okay, we cannot do that. So in this case, it will throw an error, and it will show a summary here that the unit test here, it ran 2 tests and it failed just only 1. Okay, so we need to fix the code or fix the test case to pass it. Okay. That's the basic fundamental of the unit testing. Is that clear or not to everyone? Okay. To write the unit test, easy like that. Import the unit test, create a class, inherit from the unit test.test case, write the test method name, start with the test underscore, and then all done. If yes, then yes in the Zoom chat. Yeah. If not, then feel free to ask me a question as well. Okay, thank you. Because we use the unit test framework here, right? That's why it allows us to create multiple kind of test cases. We can assert equal, assert not equal, assert true, assert is can be used in a list or dictionary, that kind of thing. Assert is instant, is in instant, that kind of thing. So it can be manipulated with the set, with the list, with the dictionary. It can be the test case scenarios will be more complex, more complicated and comprehensive rather than just a basic return value assert equal, that kind of thing, like a docstring or in the basic assert function. Okay. Okay, let's try to do something more complicated here. This is a stack. Okay, stack is a basic data structure. Okay, probably everyone had learned this one before. Okay, so stack, right? We have the stack. The basic two operation is the push and the pop. Push the item in, the data element in, and pop to take it out. Okay, so that's the basic the basic algorithm of the stack, right? So how to implement it? Draw. Okay, draw. Let's say that we create a class stack here, okay, and we implement it using a list. Okay, self.data equal to a blank list here, and we create two operation here. Okay, that's a constructor method. We create this one, and then we have 3 operation. Okay, first is empty or not, and it just return not self.data. Push, it just add the element in, and pop just take the element off. Okay, return it out, remove it out. Okay, so that's the 3 basic operations of the stack.py. Okay, then the next question is that how can we test it, right? So because I mean myself, if I look at this code, I would just say, okay, because we have when we write the test case, go back to the basic principles. We want to test every possible scenarios. Okay, that means every possible scenarios, then to get the 100% coverage as well, right? In this case, what are the scenarios that we have here? First, we need to construct the data. Okay, construct the class. Okay, create the class. Then these 3 lines will be executed anyway. We can execute this operation as well. It's empty, so these 2 lines will be executed. Run assert this one as well, run the push, run the pop. So every line, just try to cover every operation here. Then we can achieve 100% coverage, right? Okay, let's see how to do. Okay, so this is what we want to test here. We just write the test file, okay, to test the stack.py. What we need to do, the test file should start with the test. Okay, this is not a good name. We should say test underscore stack.py. That might be better. That's a naming convention, right? And next, the first and foremost, as I mentioned before, we need to import the unit test library. We need to import the stack file. Okay, you can import stack or from stack import star. Anything is fine as well. We create a class. The naming here can be anything, stack test or test stack. Either way is fine. Okay. Inherit the unit test library. Okay, unit test class. Okay. And then we create this one. Check if a stack class can be created or not. This is a setup. Okay, setup. This is the part of the unit test as well. That's the precondition, right? Whether we can create or not. Okay. Self.stack equal to the stack. Okay. Stack object. Then we get the stack object here. Then we assert the first one. Whether when we create, right, it should be empty. Then we test. That's the first test case. We want to check if a stack is empty or not. So self.stack.is empty, and it should return true, right? So that's why we use the self.assert true here. So we expect after calling this method, it should return true, and we want to assert whether the expected output here is actually true or not. So that's why we use the assert true. Okay, now that's good. Test empty false, it means that, let's say if we push a number here, a data element here, 0 into the stack, it should not be empty at all. That's why this is another test scenarios as well, right? So we test the same method is empty when it is actually empty, and when it's not empty, it should not be empty. So it should return false. Okay, so that's a two scenarios. It's quite comprehensive, which is very good. We can also test another scenario as well, right? Like test empty. Is it really, really empty? Like if we push the data element here, okay, the 0 into the stack and pop it out, okay, remove it, and then test whether it is actually empty. It should be empty, okay? So that's another test scenarios. We have 3 test scenarios here, which is very good. And then to run it, right? We just run python-m unit test. Yeah, and the test file here. Then we will get the results. Run 3 tests in X seconds, and then all done. Okay. So I think the 3 test cases are passed. Okay. But when we run the 3 test cases here, we don't know whether we don't know how many lines that are actually executed. Is there any lines that we haven't tested yet or not, right? So that's why we have another mechanism, which is called code coverage. So the code coverage, it will show the proportion of the code that is covered by the test case, okay? So yeah. And it is normally used like in the unit testing level as well. It can be used to answer these 2 questions, right? Whether we test enough or not, whether the test suite that we design is enough or not, and are there any test cases that we should add to the test file, right? And there are different types of the code coverage as well. The basic easiest one that we will use in this week is line coverage. We just focus on how many lines of code that are executed by the test case, but it can be other types of code coverage as well. It can be higher granularity or lower granularity. For example, at the function level, how many functions that are executed, how many statements or lines, okay, the same, that are executed. If there are branches, for example, if else, okay, condition, whether we cover all of the branches in the if else or not, right? And there are more in the more types of the code coverage, which we will cover in white box testing part as well. Which week? Okay, help me. This is week 3. 4, 5 will be black box. Okay, 6, 7. Okay, 6, 7 we will talk about the white box testing, and we will talk about more types of code coverage as well. But for now, we'll just focus on the line coverage. How many lines that are executed, all that, okay? This is what we do in the ED STEM as well in this week's studio, okay? Let's say we have the, what is that? mymat here. Let's take a look at this one. This is a Python file. Okay, mymat.py. We're gonna create a calculator here. I would say mymat library. Okay, we have 4 methods: add function, add method, add subtract, multiply, and the divide. Okay, easy. What we need to test, of course, we can, if we call four methods here, probably we will get like 100% code coverage. Okay, but let's start with the basic one. Let's focus on the add method here. Okay. What we will do, we just create a test file here, test_mymat.py. We import the mymat library here, right? Okay, this is what we want to test. And we import the unit test, the testing framework. We create a class test_add, okay, test_add, and inherit the unit testing class here, okay? And then we can write some documentation here using the docstring, okay, easy. And then this is the first test case. We want to test the add integer. Okay, we want to test, this is the test scenarios, add integer. So the integer here can be, in this case, it will be 1 and 2, right? So we just call mymat.add here to call the method that we want to test, okay, with the input values, okay, 1 and 2, okay. So 1 plus 2 should be equal 3, okay. So the 3, it will return to this variable, and we just use the assert equal, whether the result that we get is the same as the expected output or not, okay? So this is how we run or how we implement the test case using the unit test library, okay? And next, once we have the Python file here, the file that we want to test, and this is the test method. Okay, this is the test method, the test case here. Then we just run the next command: coverage run test mymat here. So this one, it will execute the test case. It will generate some binary file in the workspace or whatever, and then you can run coverage report, right? To print it out. What is the code coverage for our test file here, okay? So what we will see here, it shows you that, what does it mean here? For the mymat.py, there are 8 statements, okay? 8 lines that are executed, okay? But there are 3 lines that are missing, okay? So we will not talk about branch this one yet, okay? So it covers just only 62%, right? 62% of the 8 lines here. And if you use -m, it will print out which lines are missing as well, which is very useful. So you may see that the line 4, 6, and 8 are not executed yet. So for what is 4? 4, 6, and 8 are not executed yet because we haven't implemented the test method, right? To test the subtract, multiply, and the divide. That's why we haven't achieved 100% coverage. But if you test everything, you get 100% coverage. Okay, easy. Okay, but again, if you go back to the last week lecture, right? Dijkstra mentioned before, okay, state that testing only show the presence of the bugs, but not their absence. Okay, we have the code here. No, sorry, we have the implementation here, the code, we have the test file here, we achieve 100%. It doesn't mean that everything is correct. Maybe there are some unknown bugs that we haven't discovered as well, okay? And then, yeah, all done, okay? So test method, so for this one, it just show how many lines that are executed as well, okay, same. Nothing more than that, easy. Code coverage 101. Is that clear to everyone? Yes, in the Zoom chat. Okay, thank you. All right, code coverage. Okay, the slides are duplicate. Okay, I should remove this one. Maybe I should remove it now. All right. Now, I will yeah, move a little bit faster, okay? So once we run the CI, no, sorry. Once we run the unit test, execute the unit test, whatever the unit that we are writing is correct, then we can execute the code coverage as well, whether we already, whether the test case that we write actually cover the code that we are writing or not as well, right? We achieve 100% coverage, but maybe this part is still manual. How can we ensure that every units in the programs work correctly, right? So sometimes because we are working with in a team, working with other people, we can use the continuous integration and continuous delivery into the pipeline as well to ensure that everything is automated, right? So that's the purpose of the CI and the CD. How can we automatically and continuously integrate every unit function into one program and ensure that everything works properly and correctly? So that's why we use the CI and the CD here. Okay. Yeah, and actually CI/CD, so we don't have to look at the test file in the code coverage. What do you mean again? I don't get it. Yeah. Okay, maybe I will continue and then I will go back to you later. Yeah, so the CI/CD, right? What is that? Actually, it follows the Agile principle because the highest priority is to satisfy the customer through the early and the continuous delivery of valuable software. We want to ensure that every unit function that we write, everything that we implement, is actually incrementally working, like deliver working software, like, you know. So that's why we need to that's why CI and CD actually follows the Agile principles, right? Okay. And the benefits of the CI is that you don't need to worry about introducing bug every time. When we write a unit function, it can cause the other, it can break the other parts of the software as well, right? So the CI actually do the integration testing, run everything properly, and then it will discover whether the code that we write is actually break the other parts or not. If the CI is failed, right? If the CI run is failed, then our code will not be integrated into the main repository anyway. So that's why the CI is like a gatekeeper. It's like the real police, okay? Whether you introduce bug to the whole piece of software or not, okay? Yeah. And that's the CI pipeline, okay? Normally, developers and the operation, they work together, CI/CD pipeline. SC, the source code repository, okay? Someone create the code, build and test, okay? Let's say this is Java, they need to build it. The CI will build and test it. And then if it is passed, then it will create the environment, deploy, and into the end users, okay? So that's the CI part is on the left, continuous delivery is on the right. That's how CI and the CD work together, okay? Automatically, seamlessly. Okay. Core concepts of the CI, okay? So yeah, these are the core concepts, right? The goal of the CI is that it will perform automatically build. Otherwise, let's say if we implement everything in Java, we need to manually build it, we manually test it, and then manually deploy it, right? So when we use the CI and the CD, everything will be automated. Throughout the pipeline. We don't need to do the self-testing. And in the first week, okay, we talk about the rapid release software development, because right now, think about Facebook or Google, they release the new version every minute, every day, that kind of thing. So any commit that successfully passed the CI, it can be automatically delivered to the end users as well. So every commit can be streamlined to the main repository every day, every minute as well, right? Every commit should be built. The main line should build the main line on an integration machine. It can fix the broken build immediately as well. One code, one commit can break the other part. If the build is failed, we can fix immediately. Otherwise, we don't want to know the surprising bugs later after we deliver the software. Okay, CI/CD we mentioned before, right? This is a real pipeline in the GitLab. Normally, we create a new branch, push the code, test the code, run the automate test, build and test. That's the CI part, okay? And then if the code is failed, we can push the fix as well. If everything is passed, it will be it will undergo code review. So that means someone else who is not the code author should review the code and approve it. If this piece of code or the merge request is approved, then it will be automatically merged into the main repository, and then it will trigger the CD pipeline. Okay, it will automatically build, test, and deploy to production. That's the CI/CD pipeline. Let's say how to do in our GitLab, Fit GitLab, right? Okay. Normally what we do, we create a new repository here. Let's say calculator library. This is one approach. Because test environment can vary from machine to machine. We want to ensure that the environment, the test environment is reproducible. So that's why we should create a virtual environment as well. In this case, we can use venv, okay? Python-m venv calculator, create the calculator environment. We activate the virtual environment here. This can be done in both Mac and the Linux, right? We just write a simple calculator program, okay? With the file name calculator.py with only two functions, add, okay? The first one, the second one, return first plus second, subtract first, second, and return first minus second. Easy. Calculator. We install the testing library here. We can use Flake 8 to ensure that our coding standard is high level and high quality. This is optional. It's not necessary. It's not mandatory. PyTest is another testing framework that actually automatically discover the test file by itself. Anything that start with the test, okay, it will automatically execute it. So PyTest is the external unit testing framework. Once we install this kind of thing, code coverage here as well, we can export the such kind of dependencies, the environment into the requirements.txt as well. So anyone can replicate this environment, right? And then we write the unit test here, okay? We import the calculator. Actually, this is quite outdated. We can import the unit testing framework as well, but this is a basic function, okay? Import the calculator, create the class test calculator, create a test addition. That's the first test method, right? Test the addition and test the subtraction. In the repository, this is how the code look like. You may have this kind of file, .git ignore, readme.md, markdown, calculator.py, requirements.txt, and the test file, test_calculator.py. And then you commit, add, commit, and push your code to the main repository, right? And then in the GitLab, you can configure the CI CD pipeline using the standard YAML file here. Okay, so it contains, so in the CI CD, it contains different stages, right? Build, test, deploy. We can customize and name it as well. We can remove the build path. We can just only keep the test, which is totally fine as well. And in the CI, GitLab CI, right? These are the four terminologies that people often use, okay? First one is the pipeline. What is the pipeline that we are going to run, okay? So the pipeline is a set of tests to run against a single Git commit. When we have one commit, and the CI pipeline, what is the pipeline is the high level. What are the steps that we want to do, okay? So one pipeline can have different stage. The stage here is the group of the related tests being run in the pipeline, okay? So stage, we talk about the fourth bullet here. Stage can be build, test, and deploy. Okay, let me repeat again. CI/CD start with the pipeline, okay? What is the pipeline that we're gonna design, okay? The pipeline can consist of multiple stages from build, test, and deploy. build may be applicable for Java, but for Python, maybe we don't need to build. We can just test it and deploy. Okay. So let's say for us, we have only the test stage, right? And what are the jobs that we are going to execute it as part of the test stage? It's called job. So in this case, we will run the static analysis, Flake 8, MyPy, Pylint, and test, unit test, that kind of thing. So we can customize and design and configure the GitLab YAML file as well. Okay. To do so, we often we just click this button, CI/CD configuration in the GitLab. And then we can implement the GitLab YAML file here. When we set up the environment, let me draw. Okay, so GitLab before for each of the pipeline, we can before we run each of the stage below here, right? We can set up the environment as well. So to ensure that every test is replicable, and this is the first stage, the only stage that we write in this GitLab YAML file. Only the test stage, and each for this test stage, we have only 2 jobs here. Is to activate the environment and run the PyTest to get the coverage. That's all, right? And the good thing about using the GitLab CI/CD is that it will validate whether the GitLab CI configuration is valid or not as well, okay? And yeah, once we set up the GitLab CI configuration here, when we look at the test result, we can also look at the test CI, look at the CI results as well, right? It will activate the environment, run the test case, everything works fine, then it will show that the coverage here is 100%, all done, and the test is successful. This CI is successfully executed, okay? And that's all, right? That's all. So what we can do, this is like a homework as well. Everyone can do try by yourself as well, right? So you can add like the multiplication in the Python file as well, and then you can write the test file, okay? Okay, in summary, I'm aware of time. Today we already covered what is the unit testing, what is the doc test, what is the difference, why do we need to use the unit testing, because it assertion functionality and how to run the code coverage as well. So during the studio, you will practice more, okay? Yeah, and when can we practice CI/CD? Actually, this week, if you look at the task 6, yeah, that's the CI/CD. Everyone will practice that. Okay, so and go back to your question on the code coverage slide. You only look at the file to be tested and not the test file properties in the report. Actually, we should look both, right? But normally, where is that? Let me see. Okay. Yep. So I would say, yes, this slide, I understand. Let me draw this one. If we implement the test file correctly, normally we will achieve 100% anyway, right? How do we make sense of test mind map? Yeah. So if we implement the test file correctly, then the coverage here will be 100% anyway, okay? But in this case, this is a little bit tricky, okay, due to the ED stem. For this case, it shows that line 14 is missing, is not executed. I think this is because something due to the terminal configuration, that kind of thing. So maybe I will show you something here, okay? Let me see code coverage. Okay. Let me clear the screen, mouse, exit, and go back to ED here. So everyone see the ED screen here, is that right? Yes. Okay. So code coverage, this is the MyMath. This is test MyMath, right? And let's say if we run this one, you will see that, so the code, there's some difference between in that slide and this one, right? Okay. You will see that test MyMath actually 100% anyway. So that's why sometimes we don't interpret it, right? There's a tricky part a little bit, okay? I'm gonna show you. Normally, if we say, how can I say? Let me think. What I'm doing. Okay. Actually, everything is all good. I'm confused myself anyway. Yeah. To confirm, clarify your question, should we look at the code coverage for the test file or not? Sure, you can. You can confirm yourself as well whether every lines in the test file are actually executed or not, right? Yeah. Mm-hmm. Any other questions? Okay, got it. Thanks. Okay, I'm good now. Okay. To show you, right? Like this is MyMath. We have 4 functions here. We have the test add here. I would just say test MyMath, right? Test add integer. It shows just only 62% code coverage because we didn't test the rest. But let's say if we want to test another one, subtract, right? Integer. Okay. And we want to test my math dot subtract 2 minus, oh, sorry, 2 minus 1. Okay. Assert equal, okay. Result 2 minus 1 should be return 1. And then the coverage will increase anyway. So it becomes 75% because the line for this one is already executed, okay? And then what you need to do, just increase, write more test case to achieve 100% coverage. Okay, that's it. Easy like that. Everyone can be a software tester. Okay, all good. Thank you so much. Actually, I'm aware of time. Just want to let everyone know that the assignment is already released. I will post, write an announcement shortly to let everyone know. Everything is available on the ED step. Okay, thank you so much, everyone. Yeah, have a good day.